Alright, so if this is blank on your page, pause it and copy it. Alright, sweet. So basically the same steps. This is the only real difference here. Multiply one or both equations to eliminate one of the variables. Alright, so you can see that if you add these, nothing cancels. Now, it's going to be easiest to eliminate the y's because I only have to multiply one of the equations to get a 2y and a 2y, and one's already positive and one negative. So what I'm going to do is multiply this bottom equation by 2. So it might even be better to write it like this. Times 2 times 2 times 2, so you don't forget to multiply everything. That gives you, top equation does not change. Bottom equation becomes 6x minus 2y equals 10. Now I can add them, and the y's will eliminate. That gives me 8x equals 16, so x equals 2. Plug that back into either one, so I'll plug it into the top. 2 times 2 plus 2y equals 6. Subtract 4 from both sides, it gives me 2y equals 2. So y equals 1. And then you want to make sure that you check your solution. So 2 times 2 plus 2 times 1, that's 4 plus 2, that does equal 6, sweet. And then 3 times 2 minus 1 is 6 minus 1, and that equals 5. So it works. That's my answer. Just a couple more examples here so you can kind of see how this works. Now I could do either one here. I think it's easier just to multiply the bottom by a negative 2, but it doesn't really matter. I could multiply the top by a negative 4 and the x's would cancel. But here I'm going to cancel the y's. So this does not change. Multiplying the bottom gives me negative 8x minus 10y equals negative 10. And now I add the equations. These cancel, gives me negative 7x and 3 minus 10 or plus a negative 10 is a negative 7. So x equals 1. Plug that back into either one. 1 plus 10y equals 3. Yep. So minus 1, and I get y equals, or 10y equals 2. So that gives me y equals 2 over 10, or 1/5. So my answer is 1/5. And how do you check this? Just like you check all the other ones. So plug in 1 plus 10 times 1/5 is 1 plus 2, and that equals 3. Check it in the second. 4 times 1 plus 5 times 1/5, and that's 4 plus 5 times 1/5 is 1. That equals 5. That works too. Sweet. So this is definitely my correct answer. Alright, let's kind of get that a little smaller out of the way. Let's try this one. So now, there's no way to multiply just one of the equations and end up with something canceling. So I'm going to have to multiply both equations. Now the easiest I think is to eliminate the y's because I already have a positive and a negative, so I don't have to multiply by a negative because I'm more likely to make an error if I do that. So what could I make these equal? What could I multiply this by and this by? Well, if I multiply the top by 7 and multiply the bottom by 5, I don't really care what happens to the other terms. I know that'll give me a 35y and a negative 35y, which will then cancel. So that's what I'm going to do here. Distribute the 7, gives me 28x plus 35y equals 42. And again, I don't care what the 28x with the 42 works out to be. I got to multiply them, right? But it doesn't matter to me. It's more important that I get a 35y and a negative 35y. So distribute the 5. That gives me 30x minus 35y. That's why I chose these two numbers. Equals 5 times negative 20 is negative 100. Now I can add those. So that gives me 58x. These cancel. And then equals 42 minus 100 is negative 58. So x equals negative 1. Plug that into either one of my originals. So 4 times negative 1 plus 5y equals 6. Negative 4 plus 5y equals 6. Add the 4 to both sides, and I get 5y equals 10, so y equals 2. Plug those in just to make sure. 4 times negative 1 plus 5 times 2. That's 4 plus negative 4 plus 10. That equals 6. Sweet. And then check the second equation. 6 times negative 1 plus, minus 7 times 2 is going to be negative 6. Minus 14 is negative 20. That works too. Alright, so this is the most work you would have to do for any one of these problems. Just to kind of reiterate, let's think about what if we wanted to eliminate x, just to get the hang of why did I pick 7 and 5 here, right? If I wanted to eliminate the x, I could multiply this top equation by negative 3 and the bottom equation by a positive 2. That would give me a 6x minus 9y equals 18. And then multiplying by 2 would give me, negative 6x, positive 9, negative 18. 2 times the second equation would be 6x minus 12y equals 16. Don't really care what this stuff works out to be. These will cancel. That's the key. If I wanted to eliminate the y, I could just multiply the top equation by 2. So for the second one, if I wanted to eliminate x's, I would have to multiply the bottom equation by 5 and the top equation by a negative 2. Doesn't matter which one of these is negative, but one of them has to be negative so that you will end up canceling. Don't make the mistake of thinking you can cancel when they're the same term but not opposite signs. If I wanted to eliminate the y, I could just multiply the bottom by a 3. So in these cases, I would have eliminated y first because there was less work to do. Alright, so in this one, if I want to eliminate x, top by negative 3, the bottom by 4. So that'll give me a negative 12x and blah 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 blah, and a 12x, blah 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 blah. And then those will cancel. Now if I want to eliminate the y's, I have to multiply both equations again. One's already negative and then the other one's positive, so I'd multiply the top by 2. That would give me a negative 14y and whatever this, and this here. And then multiply the bottom by 7. That would give me a 21, a positive 14, and a 21 here. So I have negative 14y plus 14y. That would cancel. So the last one, you should be onto the pattern by now. Multiply the top by negative 7, bottom by 4. Here I'd multiply the top by 3 and the bottom by 5. One's already positive and one's already negative, so I wouldn't have to worry about the negative sign there. So again, what you should be able to answer this without me even doing it. No solution looks like 0 equals 5 or 2 equals 3 or something like that. Infinite solutions, not all real numbers, but infinite solutions looks like 0 equals 0 or 2 equals 2 or x equals x or something like that. Alright, so good luck. And here's your U-try. Now remember, with a multiple choice, you can just plug these in and see which point works for both equations. You don't actually have to solve the third one. Alright, see you next class.